Hello everyone, my name is Trisha from BVRIT EEE. I have designed a three-phase RSM motor, that is Synchronous Reluctance Motor. It is a type of synchronous electric motor that generates torque through the reluctance of the rotor to align with the rotating magnetic field of the stator without the need for field windings or permanent magnets. So coming to the designing part, in topology, I have given the values for stator, air gap and rotor. They are like outer diameter, inner diameter, length and number of slots. For the outer diameter I have chosen 270 mm and for the inner diameter I have chosen 165 mm and the length of the stator is 80 mm and the number of slots I have chosen is 36 and the air gap length is 0.7 mm. And for the rotor, the outer diameter is 163.6 mm and the inner diameter is 50 mm and length is 80 mm and number of poles are 4. This is a 4-pole RSM motor. And coming to the housing part, first in design, I have chosen a circular type and given various like dimensions for this. Like thickness, frame thickness I have given 10 mm and coming to fins I have given parallel type of fins and set the different dimensions like number of fins and fin length, fin height and interfin space and also fin thickness. And coming to the shaft part, in shaft part I have given the dimensions for the shaft and here I have used the bearings for the mechanical support. And for the bearings also I have defined this with different types of dimensions for length, width and all the dimensions I have given here. And for the salience type, this is saliency shape I have chosen this. We can see over here and I have given various dimensions like barrier inner thickness, outer thickness and all the dimensions we can see over here. And coming to the slot part, these are the slots. And in winding I have chosen star connection and the number of parallel paths is 1. And for the coils I have chosen circular type and the number of turns per coil is 8 and the number of wires in hand are 14 and the wire diameter is 1.024 mm and inter wire space is 0.01 and these are all the dimensions I have chosen here. We can see the diagram over here, we can see it. And then for insulation I have given this and for end winding I have chosen U shape. And these are all the values I have chosen. And coming to cooling part, for the external cooling I have chosen the convention mode as forced and we can see over here the like fan tip speed ratio, altitude, flow origin and the machine orientation. And for the internal cooling I have chosen convention mode as natural. And coming to the material part, for frame I have chosen aluminium and for the magnetic circuit I have chosen this. For coil conductor copper and for the insulators Nomex. And for the cooling for internal fluid I have chosen air and for the external fluid also air. And coming to the testing part, so here we can view our RSM motor like based on all these designing parts. In coming to test, there are different types of tests and we have to perform various tests for this motor. First we are having characterization like model For this I have given the values, and here we'll get the inputs and the winding characteristics and various graphs we can see over here. We have various graphs here in this, like q-axis dynamic inductance and all the graphs over here. Electromagnetic torque and stator iron losses. These are the various graphs we get. And coming to the thermal, we can see the temperature radial view here, and external fluid temperature and all the inputs we can see here, like how and the speed, like 1500 rpm we can see here. This is temperature radial view and axial view. And coming to working point sine wave, here we are having winding characteristics, and also we got the efficiency of 92.511, and line current, line voltage, we got all the various values here we can see over here. And the graphs, flux density in air gap versus mechanical angle, here we can see the graph. And coming to performance mapping, here also we can see the various standard parameters like current definition mode, max line voltage and additional losses, and the winding characteristics, winding temperature, and the machine performance like operating mode, and the mechanical torque, power, and machine efficiency I got here is 97.383. And we can see the machine performance, maximum speed point, and there are graphs like mechanical torque versus speed. Current versus speed graph, and voltage versus speed. These are the various graphs we can view here in working point sine wave. And coming to mechanics, here we can see various inputs and winding characteristics and the efficiency, mechanical torque, and overall sound power level. And here we can see the model analysis like natural frequency versus number of lobes, and the radiation efficiency. These are the various graphs we can view here for the mechanics part. So we have tested for the characterization model and thermal, and working point sine wave, and performance mapping sine wave, and the mechanics NVH. After testing we have to export it flux 2D, and we will get a report. we have so we'll get a report here. So based on our design and testing part, so in design we'll get the radial view and axial view. This is winding view and all the configurations that we have given the values for the outer diameter, inner diameter, all the given chosen or values will get here. This is rotor saliency and stator slot. So all the given values we can see in this report file. You can see over here various graphs in this file that we have got in the testing part, and also various configurations like we have seen this in the testing part, and so we'll get a report based on all the testing of our motor. Then we have to export it to flux 2D. So this is a another type of knowing the efficiency of the motor. Then we have to export it to flux 2D. We have exported into flux 2D. Here we can see different parameters like meshing tools, aided mesh point, air gap mesh point, infinite mesh point, and for also mesh line, aided mesh line, infinite box mesh generator. These are all the parameters we have given in the flux 2D. So we can see aided mesh points here, and these are all the values. And in the solving scenario, we can save our file. flux2d.flu. This is our saved project. So finally I have designed reluctance synchronous motor using Altair flux motor, and thank you for giving me this opportunity.